Last semester, I took machine learning for trading, and I found that for a novice, the content was presented in an order and speed that made the final project less impactful, um, content retention wise, than it could be. It was kind of the addition of hyperparameter tuning, deciding between Q-learning and random forests, the new performance requirements, and just the overall number of smaller topics to cover, um, caused me to focus more on getting it done, the project, than actually learning the content behind it. And when I was doing my research logs, I learned that for novices to a subject, visualization is a more effective medium than, say, reading texts. And on top of that, simulation is even better, as it increases engagement and allows people to conduct active hypothesis testing, which is really important in order to recognize when our ideas about something are incorrect. If we have a bad concept of how a system works, it's important to be able to actually test that in real time. And if it's wrong, we can develop a new hypothesis and test it again, and so on and so forth. And given that about half of OMSCS students don't actually have computer science degrees going into the program, I think it's fair to say that aside from myself, there are a large number of people taking machine learning for trading that are novices. Now going into the tool. So I decided to make a tool that helps people going into the final project, to make sure they understand the complexity and maybe develop some intuitive understanding of the hyperparameter combinations and their impact on model behavior. Um, if possible, I would love if you guys watching this could give me feedback about making a responsive website, um, and just any feedback in general, really, for the design of the tool or implementation. Yeah, so today I'll be presenting my low fidelity Figma wireframe. Um, and these sticky notes you're supposed to see them. Just covering some of the notes of what I'm discussing. So this first page is just the home page, and it's just going to be covering some basics, like some tips for students in the class. Ideally, they use this before Project 6, which is a prerequisite for the final project. And they just read some basic tips and tricks you should know going into the final. Things like choosing good features. I might add a little bit more to this homepage to give a little more information. So first thing people would do, and I want them to kind of just jump um, into using the tool. Um, they'll have different combinations of hyperparameters and this kind of historic view of what their past testing has done. Um, what they'll do is they'll either choose a preset configuration, which will be like a number of, you know, poorly trained or optimized models that'll have different issues. You know, maybe they're overfit, or they could just be poorly fit, and the challenge will be for people to fix them, make them perform better. So say they edit max depth and they decrease it to 2 and they hit run, and they find, hey, this actually brought my validation and test performance up a little bit. It dropped the in-sample performance. So you might, for example, say it's not overfit or it's less overfit. um, and I haven't actually decided on the stats that'll go here, but I'll be displaying some performance statistics, things like that, to let people understand how the behavior has changed. And then say they edit the minimal sample split because they were thinking here, it's 3, it's overfit. Maybe I want to make sure it doesn't split too many times. And this tree is not actually obviously uh, created by anything, it's just random. And they find that, oh no, it actually tanked the performance because now it's not fit to my data at all. Uh, so yeah, the goal here is just let them test it, see how it impacts the performance, and maybe they'll probably set it back to 3 and try to edit something else or make a less extreme change. So they can reset it, go all the way back. Maybe they just go to the preset tree configurations, choose a different one. The goal is to let them visually see how the performance has changed. And because the class has both a decision tree or a random forest as well as a Q-learning uh, final project option, you obviously need a Q-learner. Um, and this is just going to be a different set of hyperparameters, right? But it'll be the same idea. Maybe you edit the learning rate, performance is changing, you edit something else, you find that it's getting better, and so on and so forth. One more thing I wanted some feedback on is that obviously there are a few hyperparameters that I'll be running, editing here, the options. Um, but there's also a few other settings that I want to have people edit and play around with. One of those being, for example, for Q-learning, how you determine if your policy is stabilized or if you've reached convergence. This example, policy stabilized, would be um, like if the actions in the Q table that are chosen for each state have changed. Another one might be, um, if the values in the Q table have changed by a certain amount. So there's different ways you can decide to stop training, right? If the policies are no longer updating or it's not worth training more, you might instead of run 50 full epochs, it might run 20. And that's another kind of decision of how you design these that I want people to choose. I'm not really sure how to best display that, as well as things like features. I want to have them choose different features to use in their training. So if anyone has suggestions of how to visually show that and let people choose while keeping the website simple, that would be great.